G'day guys, welcome back to Marky Mark's 372 cubic inch small block Chevy build. Today we've changed location, we've come down where the car is and we'll have a look at that in a minute. We've had a bit going on this week. 2 days ago went down and picked up the turbos from Adelaide Turbo Services down the other end of Marion Road. We spoke to Bill Keane, the owner down there, so we'll have a look at that as well. And so today we're going to dummy up an engine and the transmission into the car. We're going to put the inlet manifold, just set it on top, and then we're going to put the water to air intercooler on top of that, close the back, and hopefully everything fits. Well, that's the plan. If it doesn't fit, we'll have to come up with a plan B or C or whatever. But anyway, let's have a bit of a look at the car.
Before we look at the car, let's talk about the turbochargers we're using on this build. They're a pair of GT3582s from Garrett. I had Bill Keane here at Adelaide Turbo Services strip them down and add in the GTX compressor and wheel to the turbos. So we removed the GT compressor wheel and housings and we fitted the GTX compressor wheel and housings. The GTX has a marginally bigger compressor wheel on the inducer side and therefore flow a little bit more air out of the turbo. Anyway, let's have a talk to Bill Keane and the guys.
Workshop here with Bill Keane. These are the turbos that we've had upgraded from the GT to the GTX 3582s. From the photos that we just saw, probably 5-6 millimeters in difference on the inducer on the compressor wheel, and so we've got some new compressor housings and Bill's assembled it here. How long have you been?
G'day Mark. I started ATS back in 1993, so I mark every turbo that I reco, and every now and again I'm surprised with something that'll come back into the workshop that might have left here 20 plus years ago, and it's come back in for another freshen up. Even these GTs have been around for a long time, proven themselves to be remarkably reliable and very versatile when it comes to an aftermarket fit up. So yeah, a good thing, and it was easy enough to swap out the compressor wheel, rebalance them, and send you on your way with your upgrade rather than replace them in their entirety.
Yeah, with a new unit.
Yeah.
What are parts like getting for them now? They not too bad, still for service?
Really good. And the only major manufacturer of turbos that has a presence in this country is Garrett. And Garrett have always been really good at backing up their product. In Australia, for us, they have always kept parts available for them.
Yep.
So there's never been an issue getting a seal, getting a bearing, getting a turbine wheel or a compressor wheel to service the units, rather than the alternative of put it in the bin and just buy a new one. Yeah. Ridiculous. And
you guys have got the ability to balance and everything in house.
Right from the get go. Yeah, our static balancer here came from Dick Johnson's workshop. Pulled the Pantech up outside my old workshop back in, that must have been back in about 94, when they got themselves out of the Sierra era and then offloaded all their spares and turbo balancing equipment and stuff. So that's a bit of heritage there.
Excellent.
And then we run VSRs and flow benches and stuff as well. But for this sort of thing, this all gets balanced on a VSR balancer, a high-speed balancer.
Yep.
And
there's a difference between these, because these are a ball bearing type turbo to your plain bearing, I guess. Different balancers used, or
a different balancer is used, but still the same principle. They've got to be in balance at speed.
Yep.
It's real simple. So
yep.
But the Garrett ball bearing product's been a very good, reliable product.
Yeah.
Just good quality oil, clean air, and managed shaft speed. All your latest turbos now come with provision to put a speed sensor probe into the compressor cover, which is a really good tuning tool, just so you know where you are on the compressor map.
Yep.
Yep,
maybe that's something I might have to look at later down the track, possibly.
Yeah, certainly, the more information you can get from your turbochargers from a tuning perspective, the easier it is for me to make sizing changes in a positive way. And I always advocate to customers that you've got two turbos here, or two halves to it, to look at when you're tuning, and you're looking specifically at your turbine end, pressures and temperatures, as well as your compressor end. and not just looking at the compressor side
Yeah.
with the boost gauge and going, well, more boost, and being ignorant to what's going on the turbine side. And those poor old exhaust valves open up, and if there's 50 plus pound of exhaust manifold pressure, it's going to make scavenging
pretty hard,
difficult. Certainly, as well as life hard for a poor old valve spring. And everything else. So just
excellent.
Look at it more holistically. But turbos have been a passion. I've loved turbos right from being involved with racing them back in the 80s to coming back to Adelaide and finding a niche here where there was nobody in Adelaide servicing performance turbos.
Well, the more I've looked around, the less people are doing it too. It's more, if you can't buy it out the box, you can't get it. So definitely places like you have here definitely help the performance enthusiasts for sure, because it's a good avenue for them to actually come and get some work done if needed on the original equipment they have.
Work or not, it's still they've got access to experience and advice that might help the project turn out a whole lot better than otherwise could.
Yeah. So. All right. Thanks very much for that.
No worries, mate.
Phil. Perfect.
Enjoy the project.
Yeah, we'll get there.
So what I've got up here in front of us is a compressor map. This is these are from the Garrett webpage. This is the Garrett website. So if you've got a Garrett turbo, you can look your compressor maps up quite easily online on the website. The turbos I have are a GT3582. We've taken the GT compressor wheels off and fitted the GTX compressor wheel. The frame size, the turbo size is the same. It's just we've changed the compressor side of the turbo and the housing. So looking at the compressor map here, we've got on the left-hand side, we've got a pressure ratio. And then on the bottom, we've got pounds per minute of air that the turbo can deliver to an engine. Pretty well, for every 10 pounds of air that we can send to an engine or the engine can consume, we can roughly say we can make 100 horsepower per 10 pounds per minute of air that engine does consume. On the back to the pressure ratio here, this is really just a multiplication of atmospheres. We start at 1 on this because if we were standing at sea level, we've actually got 14.7 psi of pressure, atmospheric pressure, forcing down on us. It's just the weight of the atmosphere. So we already start off at 1 atmosphere, which is what this is really saying here. Now we've got atmospheric pressure. The next thing we got to look at is gauge pressure, I guess. Gauge pressure, if you've got a gauge hooked up to your inlet manifold and you're looking at the gauge with the engines turned off, the gauge will read 0. In actual fact, we've got 14.7 psi on that gauge. It's just on a gauge pressure, that'll read 0 when the engine's not running. Now, absolute pressure is an addition of gauge pressure plus atmospheric pressure. So atmospheric pressure is 14.7 psi. Let's grab the calculator here. Something I prepared earlier. So if we've got, excuse me, say 23 pounds of manifold pressure gauge, we've got 23 pound wastegate springs in, and that's what we got is 23 psi in our manifold pressure, gauge pressure. To find absolute pressure, we just add the atmospheric pressure of 14.7, and that'll give us a total of 37.7 psi. Now to find the pressure ratio, we just divide that by 14.7, and that'll give us a pressure ratio. So we've got 2.5, say 2.56, let's say 2.5 here. So if we've got 2.5, we run across the line to the edge of the compressor map, and this is pretty well the maximum amount of air that this turbo will flow at 2.5 pressure ratio. Now if we run this a line straight down from that point to the bottom, we can see that this turbo at that pressure ratio will flow about 66, 67 pounds per minute of air, or in horsepower terms is 660, 670 horsepower available air. If we go up and have a look at GTX wheel at the same pressure ratio, if we run across the line to the extremity of the map and then go down, we can see that we're actually on 80 pounds per minute. So So we've gone from 666 to 67 to 80 pounds of air a minute, meaning one turbo is now capable of supporting 800 horsepower. We've got 2 turbos, so we've got a total of 1600 horsepower of available air that could make a possible 1600 horsepower.
We got going in today into the car, just the old engine, the one that's got the cracked block, and the transmission just got it sitting there. But this is the Ultima GTR. Yep, I guess I purchased this. A little bit of history, background on this one. Purchased in 2004 from Ultima Sports in the UK. They're a kit car manufacturer, and this is an Ultima Sports, the GTR. I started building it in 2008 and had it finished, registered on the road in 2011. So yeah, this is the basically the second engine going in the car, because of obviously the block we've got here today is cracked, which is obviously no good. So we're going to get the back off of here, going to get this off, then we'll sit the engine in, put the transmission in, and we'll put the back on, and we'll close it up. Hopefully everything will fit underneath. So we got the back off, pretty stress-free. Now we'll get the engine in the engine bay here. And looking a bit sad there, could do a bit of a clean up, but get the engine and transmission sitting in there, and then we'll jig it all up. Alright, we've got the engine and gearbox just sitting in there. We'll stick a head on and we'll pop the manifold on. I've got Jace here helping me out today. Hey Jace, how you doing, mate? Yep.
I don't know, I was going to be on camera to put some makeup on.
Makeup? Yeah, you could probably do with some makeup. So we'll get rid of the block and tackle, clean up a little bit here, pop the head like I said, and then inlet manifold, and we'll bring the intercooler in, sit that on, and then we'll bring the back hood over and stick it on and see if we've got some clearance. They're not. Oh, there I fell.
They make heads too.
Yeah, they are. They'd probably flow alright, who knows. Alrighty, let's get the head on here, pop him on, Jace. Now it is to sit on the dowels and then pop the inlet manifold here. Should have grabbed 2 heads, I guess, but anyway.
Would have made a lot of easier.
Would have. Alright.
That's him.
That's him. Well, that's dummied up. We'll get the intercooler in and we'll put the top on them. So just before we put the back hood on, we've just dummied this up quickly. The intercooler. I need to make some sort of spacer up or adapt something, because I want the intercooler to sit in this orientation with the throttle body hanging out the back of the engine. It sits up pretty high on the car, but we might still have enough room. If not, we'll have to work around making it maybe a little bit lower. Okay, so we have the back on. Jay's just eyeballing with the torch. Let's get in the back here and have a bit of a look-see.
I don't know that you put 2 in there, but close.
Oh, it's really close.
It's got to go down another 10 mil. Can you see that?
Not really. Yeah, so we've got a little bit of clearance. We've actually got probably half an inch there, looking at that.
Throttle body end is close.
The throttle body end will be close, definitely. But we can come down 10 mil on that spacer as well. Or maybe even go get up. Yeah, trying to get them to have a look, see the clearance. Maybe even go. It's on the front here, Jace. I can't see nothing. Well, we've got room that does fit. We just need to fine tune it a bit, I think, and we'll be right. Okay. Thanks, Jace. So, get this open, back again. Got rid of the, put a thinner spacer on, and this one's machined on a bit of a, about 5-6 degrees off of that, which is kicking the top of this back a little bit. So we'll shut the hood, and we'll have a look up the back, see how much clearance we have. So we'll look up the back pipe here. Yeah, it looks like we got, oh, what do you reckon, Jace? 25 mil or something like that?
About an inch there.
I reckon we've got plenty of room for a throttle body to come off the back of that. Excellent.
See you, Josh.
Alright, so that's a good result. We'll now take this manifold back to the shop and bolt in onto the engine, screw it down, and then we'll make something up and adapt an adapter, or we'll make something here to get that intercooler sitting on the manifold in the right orientation. That'll work.
Yep.
It's been a couple of days since we've got back from the Ultima measuring up the manifold. We've ended up buying a spacer and had to machine that on a bit of an angle. In normal cars, you know, your sort of manifold sits in a bit of an angle. You know, you got your transmission on the back, and that goes in the engine tunnel. And manufacturers of the manifolds, they actually machine the carby platform where the carby sits on the manifold at a bit of an angle, so the carby sits flat because the engine's on a bit of a slant. So in the Ultima, it's a little bit different. The Ultima, the engine and transmission sit plumb level, so which would tilt the throttle body or the intercooler in this case forward a bit. So we've got that spacer here again, and we've machined it. The other thing we wanted to do was, this is the intercooler plate off the bottom of the intercooler. It is designed to sit longitudinal like this on the manifold. Of course, we've got the spacer so it sits level now on the manifold, but we also need to turn it 90 degrees to just suit the car application a little bit better. So what we've had to do, we've had to mark out a machine for additional holes here, along with machining some additional holes in the spacer, so we can actually turn the spacer, well, not the spacer, but turn the bottom of the intercooler box 90 degrees on the spacer. And in doing so, bolting the spacer up, we've had to drill 4 holes and just drilled and tapped to 10 millimeters, actually 10 1.5 pitch threads, to bolt the adapter on, and then the intercooler will bolt to that. Anyway, just got to clean a few things up. I've got to assemble all this, then get in here with a die grinder, smooth it all over, because this is a little bit smaller than the holes in the, as you can see, there's a little bit of difference there. So we need to die grind some of that out. Make that the same size, clean the manifold up, and then get it stuck on the engine. The other thing to note with the manifold, where it sits down, we've obviously drilled and countersunk, or the square countersink on these holes. We've got enough purchase underneath the bolt to hold this down, but the stud itself, we've got some new hardware here. The stud itself will just need to turn down the head of the screw here, the diameter of this, so it neatly fits in the countersink. So we only need to take, I don't know, what's that, 1 mil, 2 mil maybe off of that, and that'll fit in there nicely. So we'll put that in the lathe and turn that down. Just thinking about how to hold these in the lathe without damaging the threads. I've obviously got to turn this down. I could probably put nuts on that, but I remembered I had a kit here, a bit of a kit with an assortment of, I'll get on there, with an assortment of nut certs that I'll use to screw down to protect the thread. I'll put that, focus, I'll put that in the lathe, hold here, that'll protect the threads, and I'll be able to turn this this head down. Yeah, righto. Got the nut cert sitting in the chuck. More some bolting. Get on there. At 1353, close enough for the bush. Okay, that's our hardware machine down. Okay, let's see if it fits. Alright, well we got the manifold together for the first time with the hat. It's looking not bad. Folded up pretty good. Just got this edge here, which we need to take out. We'll mark that with a pen. We'll get the die grinder out and just smooth that over. Probably, I'd say, not make it flat, but radius the edge there, and sort of try and make it a natural curve into the port runners, or the manifold runners to the port, to the head. And then we'll take it outside, we'll give it a clean up, and get it bolted to the engine. We'll mark this and we'll just take the die grinder to it, to the adapter spacer, and then we'll leave the spacer on. We'll just blend the bottom section here in situ and start grinding. Like having a die grinder with a longer shank, you sort of get your hand down here and have a bit more control over the bit when you're grinding. Kind of handy, not essential. And we're just going to work up to the edge of where we've marked it. Get a glove on because it does get warm. Spin him around a bit. So it's not looking too bad. Follow the edge of the black line.
We'll go right around and then attend to the inside. Woo, get warm. Not bad, not bad, not bad. Alright. Let's get the marker. I think I will take this off. Let's come up to the edge of it. Just a little seal pick using here. Let's get this plate off. Okay, got the plate off. I don't know if you can see it on the camera. Yeah, there we go. We've scribed that, so I'll figure out how to hold this down on the bench while, yeah, while we grind it out. Well, while it's a little bit agricultural, I think it'll work. Just a clamp here on the edge. Takes off, I guess. Alright, got a cartridge roll and blend that in. Screwed the adapter plate back on. Got a barrel roll, or cartridge roll, barrel roll, whatever you want to call it, kit here from Summit. A couple of different length arbors. And what I'm going to do is just blend this in around the edges, and that is us. Find a glove. Not too bad. Alrighty. Keep on keeping on, get that done. Well, that'll do it. Well, it's time to get this this manifold bolted down. It's just sitting on the engine at the moment. Just sat it on there to have a look at the ports. They look like they've matched up pretty good, so I'm happy with that. We've got some gaskets here, some Felpro gaskets. These are a 1206 part number gasket. The hardware is all cleaned up, ready to go. They're an ARP stud, basically. So they're a stainless steel stud, 3/8 bolt, which will go in. I've got the instructions here, which we're going to follow a little bit. It's saying to do the bolts up, and it's got a sequence there of the bolts on the manifold, go around twice, tension them up to 25 foot-pounds, as it says here, 25 lb-ft. So we'll get that torqued up to 25 foot-pounds using the torque wrench. I've used torque wrenches before manifolds, and I've also torqued manifolds up without the torque wrench and haven't had a problem. But in the AFR manual, it's saying that
Torquing. We strongly suggest not using a torque wrench. I'm going to use a torque wrench. 25 foot-pounds. Standard 3/8 bolt is about 32 foot-pounds plus or minus 4 or 5. So I think we'll just sneak them up to 25 foot-pounds, see how they feel under the torque wrench, and go from there. Alright. Dog next door. Let's have a bit of an epileptic fit. We've just got a pump pack with some solvent 143, and we're going to spray a bit of that on a rag, and we're going to make sure the surfaces are nice and clean and dry for the gasket. We don't want oil on any of the mating surfaces. We want it to be nice and dry. We don't want leaks. So clean them up, and the ends as well, or some call them the China wool. Also says in the instructions, when you get the Felpro gasket kit, it comes with these little cork gasket doodads that you know, go on the ends. It says not to use these. Like so, it says not to use them. So it says to use RVT or silicone. It says in the instructions just to use some gasket cinch, Adelaide part number. I don't have any of that. So I've got some super glue here, just going to give it 3 dots, small dots, in a couple of locations. Going to drop the gasket over the top here and line up the ports as best as possible with the bolt holes, central. Okay, just give that a couple of seconds to set. A couple more seconds to set. Okay, beautiful. Right. Get the silicone on the ends, and we'll drop the manifold on. Got some of the RVT from Worth. I spotted the centers with the super glue, so I can get underneath and just put a smear on the back side of the gaskets here of RVT. Just a light coating. Just on the one side, not both. Hopefully I've got enough RVT left in that can. If not, I've got a couple backups that we can use. It actually says to do this in the instructions, little block instructions there. Alright, let's lay this in. 1/4 inch thick it reckons. So let's go. It's about 1/4 inch high. And the front. Looks really good, these things. enough there. Alright. Here we go. Well, it's just sitting on there at the moment. I'm just going to look down the ports here to see if we need to go backwards or forwards, which it looks like we do, just a bit. They look pretty good. Instructions also say to put a bit of silicone on the threads of the bolt, because these holes, except for the very end ones on the manifold, go into the crankcase. So if you don't put some sealant on, you'll end up with some oil coming up. We'll give it the juice on all of them, and we'll throw them in. Right, let me get them juiced up. Instructions here. It looks like we're going 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12. So we'll just nip them up. They're just nipped up by hand at the moment. So we'll just go along and lightly nip them up. I might give them a bit of a tap with a mallet as well, just to make sure we're sort of in the groove. Things look lined up okay. Looking down the runner here, doesn't look too bad. Seems to be snugging down okay. I'm not using a lot of force on this at all. Alright, let's see if we can get a torque wrench out. Not getting much more on those as we go. So I've got my torque wrench out here, made this little tool up long time ago. I think I made it up for 3500 series Caterpillar diesel cam segments, actually. Just got the torque wrench set very low here. I'm just nipping them up as I'm going along. I've got this set to 10 foot-pounds at the moment, and obviously torquing them up at 90 degrees to the torque wrench. If I extend this any further that way, it's going to give you more torque, so that's what we're doing at 90 degrees. So just keep going around until we get to 10 foot-pounds. This, what are we up now? We're at 20 foot-pounds. So we'll get a straight wobbly socket on this one, just to check, which is what I've done, just to straight onto it. And see if we go. And we actually turn it just a smidge more, so we're good to go. 25 foot-pounds. Actually feel quite good, they're torquing up nice. You can sort of feel when a thread starts to go a little bit doughy and the bolt's going to strip. These are feeling quite good. I'll let that sit for, I don't know, 10-15 minutes and check them again, and that should be us done. Feeling good. Feeling good. Okay guys, so that's it for this one. We've got the manifold bolted on, and all going well. It's turned out pretty good. So we've got the plate there, looks like it's going to fit up nice. Really all we've got left on this build now is to install or fit up all the accessories, oil pump adapters, water pumps, engine mounts, get the injectors in, the injector rails, wiring loom, and then we'll probably concentrate on the exhaust manifold. I do have an old exhaust manifold that we can use, but I think I might make something new up there. Probably make it out of some of this 321 stainless steel Schedule 10 pipe, and then yeah, get it down to the dyno. But until then, keep it on the track, guys.